All right. In our unit on numbers and algebra, we really need to talk about notation of numbers, especially the sets of numbers, because you'll be asked to classify numbers according to their sets, be able to work with these sets. So let's talk about the number sets. We start with the natural numbers. Natural numbers, these are counting numbers. This is, cavemen even could count in some way, shape, or form. In the United States, we tend to separate out the natural numbers and the whole numbers by adding 0 to it. In IB, 0 can be included here. And it's represented by a big fancy N. Sometimes maybe just an N, but it's an N for natural numbers. Now, people were fine with counting, and they could add these together and be fine, and they can multiply them together and be fine. But when you go into subtraction, if you think about it, you can't really always subtract to these numbers and get something in that set. For example, 5 minus 2. Now you've got a negative number. So negative numbers don't live here. So what they did was they took this set of numbers and they extended it by putting in also all the negative numbers. So here's where your -3, -2, -5, everything negative lives here. Put them all together, and you have what are called the integers. Now here's where notation really gets kind of crazy. Integers are represented by the letter Z. I know that sounds weird. The reason it's called Z is actually, and I'm going to mispronounce the word, Zahlen. That's the German word for numbers. So that's where the Z comes from. And if you'll remember from Algebra 2 why I isn't used for this. There's other stuff that we use I for. Now, okay, so we're fine adding, we're fine multiplying still, and subtracting now. We're good. But division. Sometimes that doesn't work out so pretty, huh? 3 divided by 1, you're okay. 4 divided by 2, you're okay. But 2 divided by 3, now you've got a fraction. So, you've got all these pretty little fractions. If you take these and all the integers, you have what are called the rational numbers. Now, the key about rational numbers is rational numbers are anything that can be written as a fraction. So let's think about it. These are fractions. Can I write any of these as fractions? Well, of course, just put it over 1. Easy as pie. Now, the symbol for rational numbers is Q. Now, Q stands for quotient, because we're dividing two things. So everything that can be represented as a fraction lives in this world of rational numbers. Now, if it cannot be represented as a fraction, it is considered irrational, not rational. These include our square roots, things like pi, e, all those numbers. They cannot be represented as a fraction, so they're irrational. Now, as far as symboling, if it's not rational, we just take the symbol for rational and put a dash out to the side. That means not rational. Now, if I take all the irrationals and all the rationals, I can put them all together and have the full number line. It's every little bitty thing. It makes it a continuous number line. And that number line is our real numbers. Now, the real numbers, of course, you know this symbol, the fancy R. Now, we want to be able to classify things according to their numbers, what set of numbers they belong to. So let's practice. I'm going to write down some numbers, and we're going to try to classify them. Now, we're going to include anything that it can fall under. So let's Start with natural numbers, integers, rational numbers, or real. And I'm not making them fancy right now because we all know what we're talking about. Okay, so the number 3, is that a natural number? Well, duh. Yep. Is it an integer? Can I represent it as a fraction? Sure, 3/1. Oh, I'm sorry, integer. Gosh, wow, that was amazing. It is in the integers. Can it be represented as a fraction? Yeah, 3/1. Is it a real number? Yeah. All of these live inside the real number world. Square root of 3, is that a counting number? No. Is it positive or negative or 0? No. Can it be represented as a fraction? No. But is it still real? Yes. 0.3, counting number? No. Integer then? No. Can it be represented as a fraction? What's a decimal? Of course it can. 0.3 would be 3/10. Of course I can represent that as a fraction. Any decimal you can represent as a fraction. If I'd add 0.25, well, of course that's, what, 25/100, which is 1/4. Everything. 12, that's 12/100. Anytime you have a decimal, you can represent it as a fraction. And, of course, that means it's real. What about 1/3? Counting? No. Integer? No. Fraction? Yep. Real? Yep. What about -3? Natural? No. Integer? Yes. Can you represent it as a fraction? Sure, put it over 1. Is it real? Yep. Now, some other notation you're going to want to know about are some set notation. So let me kind of talk through some set notation real quickly with you. Is an element of has a very unique little symbol. Is an element of is going to have a little e with it. I know that's kind of weird. I'm trying to find an example real fast here. There we go. So I could say 3 is an element of, and gosh, I could have named any of the sets, right? I'm just going to go ahead and put natural numbers. This means is an element of. Other notation, intersection. What if I said I wanted to look at, can you find an element that is in the intersection of the reals and the natural numbers? So something that's both real and natural number. Well, that's kind of silly because all the natural numbers are in there, right? Any of them would work, but it's got to be a natural number. This little symbol means intersection. What about the intersection of rational and irrational? Is there anything that can be in both? That would be what I consider a null set. There's nothing. Nothing is in both. Now, what do I get if I took and did a union? That symbol means union. What if I did the union of the rationals and the irrationals? What am I going to get back? Everything, right? Because something's either rational or irrational. Now, if I put it all together, I'm going to get back my real numbers. Let's try another one. This one's kind of fun. What if I said I wanted to find an element? What would I get if I took the integers and intersect that with not a natural number. So what would be an integer and not a natural number? Well, that would be a negative number, right? Any of them. I can pick any one of them I want. So you'll be getting more familiar with set notation throughout this class, but I just wanted to kind of introduce it a little bit as it dealt with these sets of numbers.